if there's an electron sitting in the middle of this table and all the lights are out, I can say, I think there's an electron here. Let me find out. And the moment I turn on the lights, the light interacts, a photon interacts with the electron and kicks it somewhere else. So the more I try to measure its position, the less I know its position. Ooh. So, because you need to, the measurement requires an interaction with it. And in the quantum scale, interactions change the state of the experiment that you're conducting. We know this, we've quantified it, we don't like it, but we deal with it. And in the act of dealing with it, you can exploit that fact for other purposes. We exploit quantum craziness to birth the information technology revolution. There is no creation, storage, or retrieval of information without an exploitation of the quantum. So, and by the way, the quantum was discovered in quantum physics as a branch of physics was discovered in the 1920s. If you were around back then and your tax buddies who don't like paying taxes, what would you have said? Why are you spending government money on the atom and on molecules? Like, you can't even see them. What good is it? I'm a woodworker. I just care about my wood atoms, right? Here I am. Yeah, shove that where your tax dollar is. And so it would look like you're wasting your own time and everybody else's money. It would take decades, 5 decades, 4 or 5 decades before we would realize what role that would play in computing, this creation, storage, and retrieval of information. And by some measures, it's 1/3 of the world's GDP is traceable to what quantum physics does for us on a computing scale. So anyone, yes. Well, I mean, there are ways to do it. There's certain industries that would still be there without computing, but they're made more efficient with it. Okay, so UPS tracks all of their trucks with GPS and with computing devices that invokes the quantum. But UPS predates the use of these tools. But you can look at profits relative to their efficiencies that are enabled by these technologies, as well as entire fields that didn't exist before computing. You add all that up, it's a stunning fact. And so my only point is that if you want today to say, why study this when we have these other problems? All I do is take you back to the cave and let's say, all right, we're in a cave. And there's a mountain over there in a valley. And I tell the tribe leaders, I want to explore that mountain and that valley. No, we can't afford to send you out there now. We have to solve the cave problems first before anyone leaves the cave. We laugh at that. That's an absurd claim to make in caveman days. I don't know if anyone did it, but that's a crazy thought because there are solutions to your problems that might exist and time has demonstrated likely exist by leaving the cave that you can then discover. So for me, exploration is not just space, all the frontiers of the unknown, biology, chemistry, AI, you know those frontiers. And then you can cross-pollinate them and transform civilization. And then the last example I give, and then I'll shut up because I want to hear you talk too. It's not for me. I want to hear you interact with what I'm telling. Here's one. You ready?
Okay.
My physics professor in college studied the universe, loved the universe, studied gas clouds between stars, and studied how would you detect a gas cloud if it's not radiating light? Well, they give off radio waves, all right? And he figured out what kind of radio waves they give off and why. And in this, he gained expertise in the nucleus of the atom. And he discovered that the nucleus can resonate. Depending on the mass of the nucleus, which means depending on what atom it is on the periodic table, it will resonate slightly differently when exposed to the same electromagnetic field. He discovered a new phenomenon in physics called nuclear magnetic resonance. It would then take a clever medical technologist to say, wait a minute, if you can distinguish one heavy atom from another, let me make a machine out of that, put your body in it, and I can then distinguish one kind of tissue from another. And thus was born the magnetic resonance imager, the MRI, arguably the most potent tool in the arsenal of modern medicine, where I can diagnose a condition in your body without cutting you open first That is based on a principle of physics discovered by a physicist who had no interest in medicine. By the way, the real title should be Nuclear Magnetic Resonance Imaging, but that's the other N word. You're not so
nuclear. They don't like that one.
Yeah, people don't like nuclear. They're less likely to go inside the machine if the word nuclear was on it. But my point is that was a cross-pollination of ideas with clever people on their frontiers looking over the fence at discoveries that are being made. It's how we got the microwave oven. That wasn't invented by a thermodynamicist. Microwaves. This is a World War II attempt to communicate using microwaves. And they found out some guy's chocolate bar melted in the microwave field. And they said, what happened there? And they did some more tests. And of course, the water molecule and other molecules common in food respond to microwaves. It vibrates them ferociously. And so you put food in a microwave cavity, the water content of the food vibrates, friction cooks the food.